Okay, what I want to do here is to review the method that we could use to have the calculator help us solve an equation like this, or like this, or like this. These are equations that were on the note sheet that you had in class, and we didn't have the time to finish these notes in class today, so this is the description that I was going to give to you. The instructions for all of this are above this equation, so maybe follow along with those instructions as I go along. The method is going to be, as the instructions indicate, that we're going to type in both parts of this equation, both expressions separately from each other. We're going to type one of them in for y1, and we're going to type the other one in for y2. So go to the calculator and hit the y equals button. The y equals button will bring up the screen that allows you to enter expressions. And you want to type in those two expressions that you're given, 5x minus 3 for y1 and 3 parentheses x plus 1 for the other. So y1 and y2. Take a moment, hit the window button, make sure that all of these are tens, negative tens and tens, or in general, if you hit the zoom button, whenever you graph a new set of equations, you should always select option 6, Z standard there. That will automatically resize the window to be whatever is most appropriate. So select that and you should get a graph. You'll get two graphs of two lines, and you'll see that they appear to intersect but just barely off the edge of the screen. So as the notes say, you'll need to change the window. So you want to look for the two graphs that are drawn to cross. If they don't, change the window until they do. So remember, this is the x-axis. The horizontal axis is the x-axis. The vertical axis is the y. And so what we need to do is to make the y component of the screen go higher. So if you hit the window button, what we want to do is change y max to, say, looks like probably 15 is going to be good enough because it only just barely wasn't enough. So we make the window go a little bit taller, and then we graph the two items again. And now we can see a bit more clearly where the intersection point is, right there. Maybe going y equals 20 just to make this a little bit even clearer to see. So there you go. Very clear point of intersection right there. So that is going to be where our solution is. To actually figure out what that point is, you want to hit the trace button. This is step 3 on the instructions sheet. You'll get a little cursor that pops up. You can see it down there. You can see in the bottom left-hand corner, x equals 0, y equals negative 3. So that's telling you the point, the specific point that cursor is on. And it's also telling you up here in the left-hand corner that y equals mx minus 5x minus 3. That's the equation that it's looking at right now. When you move the cursor to the left or to the right, if we move it to the right towards that point of intersection, you can see the values of x and y changing as the cursor moves. So we're going to want to get that point pretty much as close to that intersection point as possible. It's looking like it's probably going to be x equals 3 and y equals 12 right at that point, but we want this to be a little bit more precise. So what we can do, as step 5 indicates, type the value that you think is right for x. It looks like 3 is probably going to be correct. So if you just hit the 3 button while you're still in trace mode, it'll automatically say x equals 3. Hit enter, and we get, y equals 12, exactly there. So y1 equals 5x minus 3. When x equals 3, y equals 12. So what we can do is hit the down key to shift the cursor to the other equation, And if I, while I'm tracing, hit x equals 3, I get y equals 12 there as well. So what I have then is I've shown that I get the point 3, 12 on both equations, no matter which equation I'm looking at. Plugging in 3 for y1 gives me 12. Plugging in 3 for y2 gives me 12. So that's telling me that x equals 3 is the solution to this equation. I can also see this by looking at the table. Hit second graph to bring up the table, and we see that for different values of x, we get different values for y. So 1, we get 2 and 6. For x equals 2, we get 7 and 9. But for x equals 3, we get 12 and 12. And this is, after all, how we can check our solutions. So it looks like x equals 3, that's our answer. As far as to actually show our work for this, on the notes here, what we want to do is sketch a graph, sketch a picture of the graph that we had. So we want to make sure that we label both equations. So there's our first one. This was, I believe that was 5x minus 3. No, that's actually the 3y equals y2 equals 3 times x plus 1. That was that one. And then the other one was a little bit steeper, like that. Kind of extend that, circle that point. So that was y1 equals 5x minus 3. And so that point right there is the point 3, 12, which means x equals 3. That's our solution. So for any of the rest of these, you can use the same thing. Just keep in mind that if their calculator, if the equation doesn't use the letter x, you'll still need to use x when you enter it into the calculator. So even if it says b or n or whatever other letter, make sure you're always using the x button, not that other letter. Because the calculator understands x, it doesn't really understand other letters. And ultimately, when you're writing the equations, it doesn't matter what letter you use.